All right, so now we've gone over the alkanes. Now we're going to go over the alkenes and the alkynes. The good news is, since we've already gotten through the alkanes, a lot of the rules are exactly the same. So now we just need to worry about the double bond and the triple bond and how to indicate that in the name. All right, so when we're talking about an alkene, alkenes are unsaturated because you've got at least one or more places where you don't have a complete saturation of hydrogen. So it should have at least one double bond. It can have more though. The carbons surrounding the double bond are going to be sp2 hybridized, because remember, if you have a double bond has a pi bond as well as a sigma bond. Sigma bonds are the only ones that hybridize. Okay. The molecular shape is going to be trigonal planar, and the bond angle is going to be 120 degrees around that double bond. So the double bond is going to change the angle, and it's also going to change the way the molecule looks. So then it changes also the way it behaves and the properties. So the bond, so a double bond is going to be a sigma bond and a pi bond. Now the general formula for an alkene would just be to take the number of carbons and multiply by 2 to get your number of hydrogens. So if you were to have 3 carbons, the number of hydrogens should just be double that, or 6. So that would be, it's got 3, so prop, and then the ending is just not going to be ane anymore, it's going to be ene. Okay, so the naming convention is going to be the same thing. So the same rules are going to be in place, except you're going to end it with ene, and you have to indicate where the double bond is, just like you have to indicate where all the branches could possibly be on the compound. So you have to identify the number, and when you number it, you're pretty much going to ignore where the substituent groups are this time, because you want to make sure the double bond has the lowest bond, like the lowest number now. So if you have a double bond or triple bond, that takes precedence over any of the other substituent groups, because that is a functional group, and then that actually determines reactivity. So we care more about the placement of the double bond. All right, so now to indicate that, you're going to, this is the traditional way, you're going to indicate the number of where the bond is with a dash to in front of the ene. This is the more traditional way. You can have people who write it as 2-pentene, but then it becomes a little bit more tricky when you've got more than one functional group. All right, so let's look at the first one. So first step, always identify the longest chain. Now this time, when you identify the longest chain, you have to make sure it includes the double bond, because that's what it really matters here. So 1, 2, 3, 4, 5, 6, 7. It's just a straight chain, so it's going to be 7. It's heptene. Now we just have to figure out the number for the double bond. So 1, 2, 3. It's the first carbon. You want it to be the lowest number possible, so it's going to be 3. So the way that we traditionally write this is hept dash 3 dash ene. And I know it's a little awkward, but this is the IUPAC way. A lot of people do end up writing it like this, though. It really just depends. So I do want you to be in the habit of this, because that's typically what you're going to see on the exam, but then again, I have seen it written this way too. So B. All right, so remember, when you find the longest chain, it has to include the double bond. So 1, 2, 3, if I go down, that's not going to be the longest. 1, 2, 3, 4, 5, 6. Okay, if I number it again, 1, 2, 3, 4, 5, 6. It's 6 either way. So it's going to be 6, which is hex. And then we have to number that double bond, so you give the double bond precedence, so it's going to be 1. It's at the very beginning. So we could do hex dash 1 ene, but really, because it's on the first one, you can just say hexene. Just because it's on the first one. If it was anywhere else on the molecule, you have to indicate where it is. All right, so now let's get the rest of it. So that's 1, 2, and there's a methyl group. 3, 4, and that's an ethyl group. Now, if you had gone the other direction, let's say that you'd gone 1, 2, 3, 4, 5, 6, it'd still be at the position of 4, which is why this system works. So we've got 2-methyl, 4-ethyl. Ethyl comes first because of the alphabet. So it's going to be 4-ethyl 2-methyl. Hexene. All right, let's look at the next one. So we have 1, 2, 3, 4, 5, 6, 7, 8. If I go 8, it's not going to change if I go this direction or this direction. If I go 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8. So it's oct. And that double bond is going to be, the lowest number would be 2. 1, 2. If I go from the other direction, it's going to be much higher. So it's going to be 1, 2. So -2 ene. Or you can actually write it as this, 2-octene. Which is less awkward. All right, so now let's identify our substituents. So we've got 1, 2, 2-methyl, 3, 4, 5, 5-methyl. So there's 2-methyl, so don't forget that prefix of di. So dimethyl. And then the numbers would be 2, 5 dash. Comma separate numbers, dashes separate numbers from letters. All right, so now let's look at this. Okay, now we've got a ring. So we have 1, 2, 3, 4, 5, 6. So there's 6. We have to include the cyclo because it's a ring. Okay, and then cyclohex. And really, when we have the ring, we're definitely starting at the 1 position for that. So it could be hexene, or you can include the number if you want, but really and truly you don't need to include that 1. Cyclohexene is fine. Okay, so now how do we number this? Okay, so when you number this, you want to make sure that the second carbon is going to be the one with a double bond. So 1, 2, you can't go, basically you can't go this way. You can't say 1 and then 2. That's not correct. Okay, so you want to make sure the second carbon is the one that's got the double bond. Now you could also go 1, 2 and then go in the other direction, but you need to make sure the second carbon, the next one, has the double bond. All right, so now let's number it this way first. 1, 2, 3, 4, 5, 6. So that gives me 4 and 6 for my substituents. Now let's do in the other direction though. So we still start with the double bond. 1, 2, I'm just going in the other direction now. So 3, 4, 5. And it looks like I get a lower number set this way. So I'm going to have methyl at the 3 and the 5 position. So it's going to be 3, 5 dash dimethyl. Don't forget the prefix. Something I want to bring up, which I don't know if it was in the rules, I don't think it was. If you were to have 2 double bonds, so let's say that you had something like this, like that. Okay, so for this one, you have 2 double bonds. You have to indicate that there's 2 double bonds, and you have to have a prefix. So when you name this particular compound, let's say we've got 1, 2, 3, 4, 5, that would be pent. And then we're going to pick the lowest numbering system, so 1, 2, 3, so 1 and 3. Now, when you do this, you're going to do the dash, 1, 3, dash diene. And so many people forget to put that di in there and then miss it. Okay, so now let's do these. These are condensed structures. So what I like to do, I like to just draw them out. So I go ahead and I draw out all the atoms too. So CH2, so there's 2 of those. That's bonding to a carbon, which is bonding to another hydrogen. which is bonding to a CH2, and that's bonding to a CH3 at the end. All right, so let's make our connections. Well, obviously here, that's where my double bond has to be. So when I'm looking at this, I have 4 carbons in my chain, and my double bond is at the very beginning, so that's going to be 4. It's bute. Okay, and then because it's at the first, I don't have to include the number, so just butene. Just make sure it doesn't have the ANE at the end. All right, so again, let's draw this out. So we have a methyl to start, or just a CH3. And then we have that bonding to a CH, which is bonding to a CH, which is bonding to a CH, which is now bonding to 2 methyls. So we should have those bonds right there. Okay, so that would complete that. And now I would be missing a bond right here, so that's where my double bond is. So now let's count. 1, 2, 3, 4, 5. So it's going to be 5, which is pent. So pentene, you have to include the number for this, so it's 1, 2. Or you could have 2-pentene. So now we've got a branch on the 4th, which is methyl. So 4-methyl. All right, so let's draw the condensed structure this time. So 2-methyl pent-3ene. So I'm going to draw out the skeletal structure first. All right, so we've got pentene. Let's go ahead and draw the pent. 1, 2, 3, 4, 5. Okay, and then my double bond is going to be at the 3rd one, so 1, 2, 3. There we go. And then 2-methyl, so there's a methyl group right there. So now let's go ahead and go through each one. So we've got a C, okay? There's nothing there. Remember, you don't show the hydrogens here, so it's CH3. It's got to have 4 bonds. Then we go to the next carbon. That carbon is got to be bonding to an H, because it's got to have 4 bonds, and then it's also bonding to a CH3, so we're going to put that in parentheses. Go to the next carbon. All right, well now we've got 1 missing bond, so that's an H. Go to the next one. That would be a carbon. There's a missing bond, so that's an H, and then we have a CH3 at the end. Okay. Well, now that we've gone through alkenes, alkynes are even easier. So alkynes will have at least 1 triple carbon-carbon bond. The carbons that are in that bond, remember you have, ooh, that is a triple bond, not a double bond. Triple. So if you were to have a triple bond, okay, you have a triple bond, that means there's 1 sigma bond and 2 pi bonds. So sigma bonds are the only ones that hybridize. So it's going to have an sp hybridization here. And you're going to see a linear shape. Wherever you have that triple bond, it's going to be linear at that part. So it should have a bond angle of 180 degrees. Now the general formula, you take the number of carbons, so if I had 3, I would double that number, which would be 6, but then I would subtract it. So it'd be at the end 6 minus 2, which would be 4. Okay, so the naming, the only difference is now it ends in Y-N-E. That's it. All the numbering system, everything else is exactly the same. All right, so let's look at this. Now, the chain has to include the triple bond. So we can number it. If we number it from here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 carbons here, but it has to include the double bond, or the triple bond. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's go the other way. 1, 2, 3, 4, 5, 6, 7. Okay, so 8 is going to be my longest chain. So it's oct. Okay, and it is at the beginning, so I don't need to include the number, so I could just put ein It's not een, it's not ein, it's ein. And now I just worry about the branch. So 1, 2, 3, that's where my branch occurs. So it's at the third carbon, and it's 1, 2, 3, 4. It's a butyl. So 4 butyl octine. Okay, let's draw these out. So I'm going to go ahead. I would like to draw the skeletal structure, or draw this out like so. All right, so now we've got a carbon, which is bonding next to a carbon, which it has 2 H's. Okay, now it's bonding to a carbon, which has an H, which also has a methyl. Okay, then we have a CH2, and then we have a CH3. Okay, so now let's fill in the bonds. I'm missing 2. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, so now my triple bond is at the end. So it's 1, 2, 3, 4, 5, 6. So hexyne. And I don't have to include the number just because it happens to be at the beginning. If it was anywhere else, I have to include that number. So hexyne. All right, now the branch. We've got 1, 2, 3, 4. That's 4 methyl hexyne. All right, so now let's draw a condensed structure. So I like to draw it out with the skeletal first. 1, 2, 3, 4, 5. Okay. And again, it doesn't give you a number here, so you assume it's at the beginning. So that's my triple bond. Now I go to the third one. 1, 2, 3. And there's 2 of those. Okay, so now I know I've got a carbon here, and it's missing a bond, so it's got to have an H. So now I go to the next one. Well, I've got 1, 2, 3, 4 carbons, so there's nothing there. So we go to the next one, go to C, and again, I've got a line here. These aren't H's, these are methyl groups, so I should have parentheses, CH3, 2, and then right here I have a CH2. It's missing 2 bonds, so it's 2 hydrogens, and then CH3. So a lot of this is just, it's practice. You just have to, once you learn the rules, you just keep practicing it, and you just do it over and over again.